So good afternoon, everyone. We are delighted to see your participation and interest for today's webinar session. Myself, Parth, I am a PhD student in mechanical engineering at Trinity College Dublin, and also the host for this webinar. So a quick few facts about our college. So Trinity College Dublin is one of the 7 ancient Irish universities across UK and Ireland, and it is also presently ranked as 101 globally by QS World Rankings. So we have organized this webinar in collaboration with the undergraduate and postgraduate representatives of School of Engineering. And this is our second webinar of the engineering webinar series, so which is titled as Smart Sensors and Tailored Environment for Neuro-Motor Rehabilitation in IoT Area. So for today's session, we have been joined with 2 more co-hosts here. I am joined with my colleague Soumya, who is a PhD student in electronics department, and he shall be handling the question and answer sessions towards the end of the session. And I'm also joined with Rucha, so she is an undergraduate student and secretary of DU Engineering Society, Trinity College, who shall be delivering a thanking note for this session towards the end. So let us now introduce our distinguished guest speaker for this webinar, Professor Octavian Postolache. He is the Associate Professor at Instituto Universitario de Lisboa, Portugal, and he is also the Associate Editor of IEEE Sensors Journal, Sensors MDPI. He is IEEE Senior Member I&M Society and also Distinguished Lecturer of IEEE IMS, Chair of IEEE IMS Portugal Chapter. He has been commended with several IEEE awards for his active work in the field of smart sensing and IoT. And thus, I hope that his talk will add a big value to our participations today. And so before handing over to the professor now, I'll just give a quick point here for all the attendees. Go through some of the guidelines as we have mentioned in the chat box for the question and answer session for those in particular who are looking to ask questions throughout the session. And yeah, I think that's all from the introduction, and I would now request Professor Octavian to take over from here.
Thank you very much, Parth. Thank you very much that you invite me for this presentation. I'm happy to give some talk about things that we are doing here in Portugal. Actually, my title of the presentation is Smart Tailored Environment for Neuro-Motor Rehabilitation Monitoring, IoT Era. And actually, few words about my institution. Actually, my university where I am teaching, it's Instituto Universitario of Lisbon. That means University Institute of Lisbon. And actually we are making the research in Institute of Telecommunication, where exists a group that is named Basic Science and Enabling Technology. Because sometimes what we are doing, it's related that use telecommunication, but actually, as you will see, focused in biomedical application, especially physical rehabilitation monitor. The outline of my presentation, few words about physical therapy, facts, technology, and challenges. Few words about IoT technology. Actually, we speak about IoT ecosystem. We are doing parts of this ecosystem, but at the end, our systems are IoT compatible. And here I'll speak about instrumented working aids, wearable sensing solution, and serious gauge for physical therapy. Some elements about objective evaluation of physiotherapy session using thermography and conclusion. The starting point of our work, actually more than 10 years ago, we are thinking to develop instrumented equipments for physical rehabilitation. And actually we're focusing in 2 kinds of patients. One, it's related stroke patients, actually people that are suffering stroke events. And we have here some numbers. 50 million people suffer stroke worldwide each year. But in these 15 years, actually 5 million are necessary to practice physical therapy. And another kind of group that we consider, this time it's a young group, that it's cerebral palsy group, about 17 million people worldwide. 2 in 1,000 Europeans suffer this motor disorder. Actually, these kids and sometimes adults, because they need intensive care on the first years. That means intensive physical rehabilitation to obtain capabilities on motor activity and to overpass the limitation that are present to this kind of cerebral palsy. But what about solutions? Speak about usually the solution are classical one, usually mechanic device without any feedback and any data storage. Usually at the end of the day, sometimes the physiotherapist will make some report on the computer or sometimes even on the paper, and it's very difficult to follow the people that are practicing physiotherapy. At the same time, because of this kind of recording, that means on the paper, it's difficult to make objective evaluation, it's difficult to make comparison with other patients, it's difficult to share the plans with other colleagues, physical therapists. And for this reason appeared the necessity to develop new kind of systems that actually are based on the existing systems, but include some elements like sensing, communication, and so on, that can provide us information and provide to the physiotherapist, but also to the patient, some feedback after a physical therapy session. And here we related objective evaluation. We have some objective evaluation in clinics, but also, again, in some mechanical way or even subjective evaluation based on scales of pain. That means after training, the patients are asked if they feel pain, which is the level of pain, and so on. Some measurements are also done with some mechanical device that also don't provide enough information after, that don't provide storage capabilities and communication. The idea is to use the common systems that exist in physical therapy clinics in order to be more easy for physiotherapists to use this kind of system, but to include some additional sensors like that can provide us information about, let's say, force, motion, kinematic and dynamic measures, quantities associated with the physical therapy session. And this kind of sensor, this kind of architecture can be IoT compatible. Okay. Sorry. Okay. What about IoT healthcare? Actually, IoT in healthcare is characterized by fast adoption. We expect 1 trillion healthcare device, maybe according this kind of device the number maybe will increase, taking into account this situation of COVID that expressed the necessity to improve even more the IoT healthcare component in society. And why this kind of IoT healthcare? Because actually we can improve the quality and effectiveness of service for elderly in the case of stroke patients. But also the IoT healthcare can provide even monitoring and assessment for patients with chronic condition, and in those that require continuously supervision. About IoT technology, I will not go in detail because it's more very known for you. But actually we speak mainly, the term of IoT comes from RFID. Actually, the first time when it was used, Internet of Things was more related to the RFID system. And but nowadays we can consider like part of IoT technology a lot of short range, long range communication protocols. We can speak about smart sensors. We can speak about mobile device and also about edge, fog, and cloud computing. As I said before, IoT is an ecosystem where we can find different components. And we try to use this kind of technology to develop our solution for physical rehabilitation. One architecture, common architecture, actually reported in literature, it's here presented. Actually, we have a wearable smart sensing solution. Here we can see different quantities, biomedical parameters, respiratory rate, pulse fall detection, and gait detection. That is very important when we speak about gait rehabilitation. All this information will have some central node or coordinator node that can sometimes present hybrid communication capabilities that can deliver the data through a local WAN base station. And after this, we can process the data on the cloud where different algorithms like machine learning can be applied in order to extract data, to extract information from the data that come from the patient. Actually, related communication protocol, here I can present some. We can see Sigfox and LoRa that normally are related to IoT implementation, are long-range communication protocol. We can see there. However, we can reach 11 kilometer or even 13 kilometer. However, the data rate is very low. And also we have another kind of protocols that actually are based on cellular network, narrowband, IoT, or even we can think to 5G to be applied in this kind of IoT architecture. One problem that appears is that actually we have communication protocols and between different devices that are using different kind of protocol like HTTP, TCP, IPv6, HTML, JSON format, and so on. However, in the last period, was considered by different application MQTT protocol, like one of the solution, maybe will be more generalized in the future. And now let's move to what we design and were doing during these last years. Actually, this first idea was to have working AD net. That means a set of walkers, crutch, and walker different models. We speak about standard walker or walker with 2 wheels walker, 4-wheel walker, and so on. And to make these systems with the smart sensing capabilities and communication capabilities being at the same time IoT compatible. We can see here that through practical, the information can be delivered through Wi-Fi, normally short-range communication protocol, ZigBee or Bluetooth, to a client side, and based on the client side, it's the data is going to the cloud or the local server, and on the server side or cloud side, the data is processing and different. The physician or the physiotherapist or accompanying person can receive information about the let's say the activity, motor activity, of the person in their house or even during the physical therapy session. Here I present three kinds of prototype that was implemented. One of the standard walker, two-wheel walker, and four-wheel walker. Actually, here I want to mention for the two-wheel and four-wheel walker the usage of, let's say, remote sensing technology based on frequency modulated continuous wave microwave radar that is used to extract information to extract pattern of gait during the usage of this kind of device. One for standard prototype, we can mention here some low-cost solution that are using a set of Arduino Mega, or maybe you know very well this platform, a set of sensor. We mentioned here on the set of sensor level, a set of accelerometer, gyroscope, magnetometer, a set of load cells, and ultrasound distance measurement in order to extract the distance between the walker and the floor during the training activity. For the same system, we developed actually two kinds of graphical user interface. One is based on Android OS, and here we can see different setup, but also we can see the distribution of center of force during the gait activity of the user. And here some image about the for some tests, we consider some tests like first route 5-minute straight walk, and we can see the distribution of the center of pressure that we measure using 4 load cells distributed on the level of the walker legs, and we can extract information if what is the situation of the rehabilitation. For volunteer like left side impairment volunteer, the right side, and volunteer without impairment. We have here for this kind of test, first route and second route. Being in contact with the physiotherapist, we observe that it's necessary to define a set of metrics that can be followed during the training session and after. Was defined two kinds of, in this case of walker, we defined risk index imbalance, risk index, and one incoordination index. These two indexes are related to capability to use the walker and also to avoid accidents. Even we define a state machine model, and was defined based on the information that are coming from the physiotherapists. That means a big part of accidents appear when the walker is used in the wrong way. That means we define here the good way of using. Let's here it's mentioned, waiting for the walker lift off, walker is flying, and so on. We define a state machine, and we can measure incoordination index that was here defined, bed usage, and total number of usage of the walker. Actually, we developed some application in LabVIEW. Here we can see with all the states, and we can observe during the walker usage the index 1 and index 2 that was defined before. Here we can see let's see if it works. Yes, we can see also if it's how it's the center of mass it's distributed, and also we can see the values of index during the usage of walker. But people are using standard walker, and after some period are moving to the usage of the crutch. Actually, here it's another architecture that was implemented. In this implementation, we are using Arduino again, but version Arduino Nano version that and also a set of sensors, again 4 sensors and accelerometer, 3D accelerometer, 3D gyroscope, and 3D magnetometer in order to extract information about direction. And the bridge between the system, instrumented crutch, and let's say cloud side was done through a mobile smartphone that is running Android, actually through the Bluetooth Low Energy, the phone, the smartphone is communicating with the computation platform expressed by Arduino. And after the data is processing on the smartphone and delivered through Wi-Fi to a MySQL database in a remote database where is running some PHP script. And after processing of the data, we can provide information to the physiotherapist and to the patient in order to motivate more for the training. So a few elements about the sensor. We can see here a load cell that was implemented, and also some flexi-force sensors that are on the hand support, are mounted on the hand support, and also the platform, the computation platform. Here some few, I will not, I think this is take some much time, but actually we developed the mobile application where we can actually make the registration of the user. And after the user registration, we create the profile. We can start the training. It is very important after the data is stored, and after this we can, according to some plan, we can provide a specific session, personalized session for each user, who can define the plan is the physiotherapist. And when the user make login in the system, practically we can follow previous recommended plan by the physiotherapist. And okay, in this case, okay, with some let's see if we can see some train with this. After registration of the user, we can move forward to the plan. And let's see, okay. And at the end, we start to define the plan and now discover of the device. And at the end, you can start to perform the training based on crutch. Here, a few words here, we can see some volunteer, and according to the exercise that was done, we can see the evolution of the force, and we can identify, okay, and also information coming from the inertial measurement unit expressed by 3D accelerometer, 3D gyroscope, and so on. We're moving forward to other kind of implementation. This kind of implementation is expressed by a serious game where the interface between the user and the virtual reality serious game is done using a smart gloves and hand and an additional device, hand band, that actually provide us the capability to navigate in a virtual reality scenario. Here are indicated some technology that was used in the system. Again, we can see that data storage was done in MySQL. We have some mobile application using Xamarin. The virtual reality scenario was developed using Unity 3D, using also C# script. And also the part of sensing part was based on Arduino. Okay, few more elements about architecture. We have some admin clinic, physiotherapist and patient. Actually, the access to the system is based on QR code through the mobile application. Related smart gloves we can see here. Actually, we have reflection sensors, force sensors, and also inertial measurement unit. And at the same time, at the level of the handband, we can see also the usage of inertial measurement unit. Related the game, two games was developed. Here we have also the prototype of the implemented system, hands down game and coffee pong game. Actually, both games were designed to provide, let's say, a way of training for the patient for the upper limb training. The technology was mentioned before, but we can see actually the usage of the Unity 3D. Also was developed some mobile application where we can generate care code according to the data that was stored in the database for each patient. Based on this care code, patient can provide the identification, and also we can receive the data that was obtained during the serious game practicing, and we can observe here the yaw, pitch, and the roll angles, but also can be selected different to other quantities. We can see here Euler angle, finger pressure, finger extension, and linear light, the, let's say, the outcome of the patient during physiotherapy. A few words about augmented reality. Actually, we're moving from the virtual reality to augmented reality. That can you see that actually virtual reality, it's also semi-immersive scenario and was practiced only for upper limb rehabilitation. Thinking for let's say lower limb, in some cases augmented reality was used. That provide a more let's say interactive experience, and also the localization of the person in some real condition is better. One of the first implementation was based on let's say internet, the iOS device that actually was considered, and also a set of wearable solution, especially we include EMG and ECG sensors that communicate Bluetooth low energy with the device, but at the same time was developed higher, let's say, yes? Sorry? Can you hear?
Sorry, Professor, please continue. If anybody has to ask any question, they can do so at the end of the session. So please continue.
Sorry. Okay. And we are using AirKit to develop the application. And actually, we have, let's say, personal advisor or personal our, let's say, this, let's say, avatar that help us to follow our plan. And at the same time, we develop another architecture that this first one don't imply 3D measurement. That means don't use depth measurement, only include, as I say, personal trainer helping people to follow the right exercise. But we are thinking more, and actually we develop another second system where we're using a structure, that structure of Cipital, that it's a 3D scanner. It's very similar to Kinect. We'll speak later about Kinect. But what is the advantage of this solution is that it's more, let's say, portable. It's mobile portable, okay? That can be included on the bridge headset, and we can make the localization. At the same time, a solution that we're using in this implementation also is the sensing floor for future chef, that actually we can validate the information that we receive from this kind of sensor that measure also the distance, okay? Some other elements that were included in the system, we speak of shimmer, GSR unit, and also that give us the capability, the measurement of skin conductivity, but also photoplethysmography. That means at the end we can know the heart rate. And the game that was developed in this case was developed for balance and gait. We can see the maze game. What we can see here is the environment without the, let's say, virtual objects, that is the maze. And the objective of the game was to catch these different objects during making the maze. Okay. At the end of the game, we can see the real path, the pathway of the volunteers. We can calculate some errors that was observed, and also information about the trajectory, errors, and velocity. And we're moving now to, let's say, another architecture for serious game. We developed different serious game for Kinect V1 and Kinect V2. The architecture of the system, can we see, is the usage of the Kinect sensor, remote sensing technology, connected to a client computer that it's actually deliver the data to a server or even to a cloud service. And based on the processing on the level of the server, we receive data that is provided, it's presented to the therapist or the accompanying person. A few words about this technology. Actually now appear that it's fortunately appear another version of this kind of Kinect. However, when we are using this together, this sensor together SDK, Microsoft SDK software, we can observe 20 body joints. That means we have XYZ information for these body joints. And based on this, we can develop actually a game where actually the interaction in virtual reality of the person, it's based on the information coming from the real joints. A few words about serious games. Concept refer to the use of computer without main purpose of providing for entrainment. In general, for physical rehabilitation, we speak about Terra games. Here is the first implementation, Terra Soup, where actually different vegetables are presented on different levels here. And actually the game was developed for upper limb rehabilitation. We test this game also in some with person for upper limbs rehabilitation in some clinics. And also at the end of the game, we can observe information about velocity, and hand angles. Okay. The game can be pre-programmed by physiotherapists. The angles of the objects, in this case vegetables, are imposed by physiotherapists between 60 or 120 degrees are distributed. And at the end of the game, we can observe also a relation between pain and the game score. In order to improve the motivation of the person, we develop additional games. One is apple harvesting. Here is the architecture of the system. Actually, the physical therapist will, let's say, define a care code for each patient after the, let's say, electronic health record of each person in the system. Based on this care code, the patient can interact with the client side part, where that include some computation platform we are using like mini PC, but also the Kinect sensor. And at the end, after practicing the data, it's stored locally, but also on the server, and provide us the information about not only about the number of the scores obtained by patient. This is maybe more important for patient, but also information about the degrees of motion of the upper limb, according to the position of the apples or other kind of fruits that was included in the gaming scenario. Here we have actually for, let's say, see if it's working well. I don't know. If not, we move forward. Yes, actually we have possibility, we developed possibility to make, to practice for lower angles when it's on the beginning of the training. And the person can also, we define the normal position according to the scenario, a virtual reality scenario. And this is one kind of, you can see if the person don't preserve the position, the right position, cannot obtain any points. And also we can see, in order to increase for upper limb and for bigger, higher angles, also we develop another kind of the game. Let's see if this will work. Maybe yes. Okay. And this the training plan impose some angles that are, as can you see, that are above 60 degrees, and the user need to make more effort to obtain a better score. Important part was considered also the interaction with the environment, and for this reason we have some good collaboration with some psychologists that we make actually some study to improve the motivation of the user. After let's say game practicing, we can visualize using mobile application some let's say user outcome, not only score, but also we can see angles, evolution in time. We can compare historical data with current data, and okay. And now we are moving to another kind of, let's say, serious game, that this time it's focusing on finger training. We are using, again, remote sensing technology based, in this case, a lip motion sensor. The architecture of the system, again, the physiotherapist will impose the training plan using an Android app that was developed for this. The user actually interact with a serious game that was developed in Unity through the, let's say, using the natural user interface that is expressed by this lip motion. Also, to start to make the login, we're using again the QR code technology. Few words actually for this kind of sensor. Actually, it used 2 cameras tracked infrared light produced by 3 infrared LEDs, and it's using 3D stereoscopic imaging in order to extract the depth. Okay. Here we can actually, we are using an SDK specific for this kind of sensor that provide us information about different points of finger. This was necessary because the Kinect cannot give us enough information for the finger motion. We can see here that we can see information about rotation, palm position, pinch stress, velocity, and so on. That is very interesting for the game. We develop a game, collect cube game, that it's a basic level. Actually, for this cube, we have different levels, first level, second, and third. We make personalization for different, here we have robot arm like for the kids to be more motivated, but also we complicate also for cognitive rehabilitation of the person that suffers stroke. We have different groups, class of objects, sports, animals, fruits, and so on. And we can see some training of the actually you can train for one hand, other hand. And at the end of the game, we can see through the mobile application, the data. We can provide information about the palm position. We can compare, let's say, outcome for different patients. But also, as I say, we develop a mobile application that make registration of the patient, care code generation, and at the end, data visualization. And related, let's say, the way of objective way to establish, to extract information about, let's say, mobility during the game was a big question, because the physiotherapists are talking with us and say, oh, virtual reality, it's enough, because sometimes we are using a real object and this is the best way, and we need to compare what is the effect on the muscle during the virtual reality game and also using the real objects. For this reason, in order to have, let's say, a remote way to extract information about the temperature on the level of the skin, but at the end, the temperature increase of the mechanical activity of the muscle, okay? And we're using thermographic image. Few words here about thermographic image. Actually, we are using a FLIR 60 camera and also FLIR Pulse Plus. At the end, we measure the temperature on the level of some muscle. In the case of the collect cube serious game, we measure before and after. We don't make measurements. The measurement is not during the game because the radiation source will change the position and will not be very effective to measure during the game. But we measure before and after. And at the end, we can see here some comparison between different volunteers. We practice the game for 1/2 minute, 1 minute, 1.5 minute, and 2 minutes. And we can make comparison when the user are using virtual reality cubes or real cubes, but not weighting cubes. That means paper cubes. Okay, and the effectiveness of the virtual reality is not, it's comparable with the real cubes, but let's say we go till 50% of muscle activity in this case. And few conclusion, smart physiotherapy expressed by target environment we can use, it's very important to use different smart objects like walker and crutch, but also we can, based on this kind of object, we can develop the activity, the quality of services in this field. The compatibility with IoT, we can so see even for serious gain or for smart objects, use it in physiotherapy is very important because we can generate report and we can increase the patient motivation and physical therapy effectiveness. And remote sensing technology, we can see here Kinect and leap motion, and also thermography play an important role in objective evaluation and physical therapy outcomes. And this work was actually sponsored by different research foundation. And thank you. I hope that was not so bad. Related the time. Thank you one more time, and I'm waiting for questions, comments, and so on. Thank you.
Thank you, Professor, for your very interesting talk. And the questions are open. I would request any participant to ask any questions. So first, type your name in the chat box if you have any questions, and then I will take questions from anybody. Anybody has any questions? Please type your name. Well, till the time, if anybody comes up with any questions, I have a specific questions for you, Professor.
Please.
You talked about various devices where you can monitor personal health and well-being. So in this instance, in this talk, you're mainly focused on creating personalized charts or monitoring fingers, your knees or joints, basically. So the sensors that you particularly use, are they optical sensors most of the time, or do you use any kind of physical sensors, let's say some kind of electrodes, especially if you're monitoring ECG and something? Or you are building your own?
It depends on application. When we think about wearable, that I say we can actually, we are using, let's say, e-textile electrodes, dry electrodes that are used on the level of the skin. And when we speak about EMG, again, that means there are e-textile electrodes that based on the carbon wires or metallic wires. And but thinking about this interaction with serious game, we try to mix the things. That means we are using remote sensing based on optical sensing, but at the same time optical based on, we have optical when we think of PPG. Again, it's clear that it's optical again. But also it's a mix with the solution based on, let's say, dry electrodes when we speak about skin conductivity, or we speak about ECG or EMG.
Okay, thanks for that answer. I am particularly interested in especially when if you're using, let's say, a color like optical sensor. So you have to do some video signal processing if you're recording, because you have to process informations from the video. That's what you said. So if you're performing video signal processing, are you using any specific colors like CIE XY, CIE Lab, or to do this kind of
actually what it's done, thinking about serious game, we the idea in augmented reality, for instance, I can give you some. We actually were using the technology of gaming. We don't use specific image processing in this game, but actually we can change the environment. We change colors, or we change sound, or we can change different things based on information that are coming from the sensor, from additional sensors. It depends. That means if we consider PPG, skin conductivity, if the stress is too high, we can slowing down the game. We can change the colors, thinking of color, we make in other work. It was not presented here. The influence of the color environment to the heart rate variability and so on. That means the colors can be, let's say, more blue, more green to decrease the heart rate, or you can let's say make the game more dynamic using red or other colors that are impose some, let's say, increase a little bit the action, because some people are liking more action and some other people less action, but we need also, is very important to follow the let's say cardiorespiratory condition of the person. I didn't mention here, but actually in clinics, usually for physiotherapy, people don't care about your cardiac respiratory condition. They are caring only to make the exercise. It is too bad. It's like in the sport. Okay, the guys make a test when they start training, but never during the training, let's say for football or other kind of things. There are cases here in Portugal that one is stop dead during the training, because you want a very strong exercise, but you never take information during the game or during the training about the, let's say, cardiac and respiratory condition. And when we speak about stroke people, that means they suffer some problem that can affect also the cardiorespiratory condition. And this is very important to follow the people during the training time.
Yep. All right. Thanks so much, Professor, for the information. And I have two more questions. So one from Zain Ahmed Samdani. So Zain, if you are there, you can unmute yourself and ask your question directly to the professor. Zain, it's up to you if you're here.
Hello, am I audible?
Yeah.
Hello, no, what do you call it? So my basic, so my question is, how much of a role does neuroplasticity play in someone's rehabilitation, in particular to stroke patients?
How much time will?
How much role does neuroplasticity play in someone's rehabilitation, particularly in respect to stroke patients?
In the case of stroke patient, each person, it's a special case, because usually during the stroke event, some damage was produced in different way, in different part, and so on. That means the games are developed, and all the system are developed to be, and the training plans to be specific for each person. That means according to if it's affected left or right side. Actually, you can see also in the motion game that you can practice only with the hand that is necessary to make rehabilitation. Also, during the, let's say, gait rehabilitation, we consider first the balance. After this, we consider different kind of, let's say, gait rehabilitation, upper limb rehabilitation, and so on. That means and always this kind of training, it's also done in clinics with assessment, because this system, it's a complementary system. That means we'll never, in some, let's say, cases, we can, to the physiotherapist, the user can train home, but usually always is necessary some accompanying person that can help and assure that no accident will happen. I don't know if this was what you want to, was the question and the answer. Okay.
Zain, does that answer your question? You think?
Yes, it does. Yes, it does. Yes, it does. What do you call it? So I actually have a follow-up question to what you said at the end. What do you call it? So do you believe that exoskeletons can replace can replace human-aided therapy?
No, only complement. It's a complementary solution, will not replace. Because
Okay, so
as I say, it's very important to motivate the person, but for safety of the person. And also, I want to say that now we are always in Zoom and so on, online, but people sometimes are feeling the human touch is very important in rehabilitation. I don't know. I hope that you never go to physical rehabilitation, but usually the physiotherapists are people that touch people. I don't say like in other kind of doctors, you go there, you stay 2 meters distance for the doctor, and he say, I will give you this and this and this. Now, physiotherapists need to touch on the person, help them, try to do more. And this is very important and motivate a lot the person. And for this reason, it's very important. But sometimes this kind of system that we develop are very important because physiotherapists told to the patient, try to do more, train this. And the person don't do anything. After 2 days, 3 days, go to the physiotherapist again and say, are you doing this? I think that I don't do enough exercise. He say, no, but I do. I did this. And what is happened with this kind of system, actually you have the record that the person working home makes some, let's say, remote physiotherapy. And at the end of the day, the physiotherapist will know if he trained additionally or never try to train additionally. Is this?
I see. Like, I see. So I've also got. So I've also got just one last question as well. So according to you, during this time of pandemic, all right, during COVID-19, is it better to get rehabilitation at home using said exoskeletons, or what do you call,
Yes.
like, with
Yes,
human
this
help?
is very good during the COVID-19. It's a very good solution, this one. But actually, you understand, we try to do to motivate the patient during the game, including different kind of scenario and so on. But always, and when I want to say, it's very important the contact with the physiotherapist. Unfortunately, during this period, many people stop the physiotherapy. Actually, because this is some prototype work in one clinics or other, yes. But I think that for the future, a generalization of this kind of solution can help during some pandemic events like now, because during big maybe 2 or 3 months, people cannot in Portugal, I don't know in UK, cannot go to the physical therapy clinics, and in this case was very bad for the people that suffer stroke or even for cerebral palsy kids, that if they stop 3 months is very bad. Thinking about stroke patient during 3 months, maybe they will never walk or do things, yes, because it's very important after stroke events to receive physiotherapy. But based on the situation of this COVID, was not so easy to make the physiotherapy in clinics. This kind of system was, let's say, considered one of the solution to make physiotherapy home, and maybe the generalization of this kind of solution can very helpful in the future.
All right, Zen, thank you for the questions. Zen, do you have any more follow-up?
No, so I don't have any more questions at the moment. But I would love to have your email to discuss further. I've also got a project I've been working on related to physiotherapy, and I would like to listen to your thoughts on it later on. So I would love it. I share your email.
You can share my email, and you can we can talk by email if you want. No.
All right.
Okay.
All right,
Okay.
Zach, you can be in touch with the professor
Yes.
using his email. If you type his name and then follow it up with IEEE IMS or IEEE sensors, you can have his official email ID. But if you can't find it still, we can mail you his email ID. There's no problem whatsoever, okay?
Okay.
All right. Moving on, we have one more questions from Luca. So Luca, if you are still here, you can go ahead with your questions. You can unmute yourself and go ahead.
Yeah, perfect. Hi, I'm Luca, and I'm in the middle of ACL rehab at the moment, and predominantly is it C plus and C++ and C# for these Unity sort of.
Yeah, in our case, we are using always C#. We are using always C# scripts, not C++. We have other approach with C++, but when we are using different kind of library for C++ related SDK, that means we develop here was not presented. Actually, we have some game developed for stroke patient, not for cerebral palsy patient, where actually was used SDK from Kinect with C++. But usually in the other kind of application, especially when we are using Unity, the C# was the solution considered.
Cheers. And is AWS sort of a recommended coding language, or sort of to get into now for cloud-based services?
Actually, you are user of Unity or thinking about because actually you have some assets that you can include all that technology that I mentioned, Kinect, and we are using also Leap Motion and so on. You can find if you are using the Unity, you can find the asset. Sometimes you need to pay something, but it's nothing more than 10 euro or something like this to have, let's say, the asset that make the interface with the other objects of the environments. That means, but always we are using actually the C# solution. That means thinking of implementation of this kind of serious game, I recommend to see also on assets what you have for your environment, for your scenario, and thinking even we develop things also for different kind of sensors that are due to low energy compatible, that you can include this kind of information in the system, in the, let's say, 3D scenario, using always this kind of scripts in C#.
Great, perfect, thank you.
Okay.
Thanks, Luca, for the question. So, any more questions, guys? We are still going to take one more question, maybe. If you have any more questions, you can just type your name in the chat box. All right, I don't think there is any more questions, but there is a special message from Killian. Says it was an interesting talk, and he himself is, I think, is a physio. So thank you. I would like to thank, on behalf of the Undergraduate Engineering Society, Trinity College as well, for this interesting webinar session. We are grateful to have you, Professor. There are many of them who actually liked the talk. And I would also encourage any participants to email the professor specifically if you have any questions that's in relation with this talk. If you, hopefully, Professor, you have funding for any PhD students, and if you have any, if you are interested in pursuing a research career with the professor under his supervision in Portugal, you can again directly contact him and ask him if it's possible to fund you guys. All right. So that's it, guys, for today. And thank you, Professor, again for joining us today.
Thank you very much. Thank you very much. And thank you for the invitation. And I hope
It
that
was our pleasure.
Okay, thank you.
Thanks,
Thank you.
Professor, for an insightful presentation. Thank you.
Okay, thank you very much. Thank you.